Hi, and welcome to section 2. It's programming as usual. In this section, we'll begin by using R like a familiar programming language, and then introduce data types and functions particular to R, which helps us work with data. There are 9 videos in this section. In the first 2, we introduce data types, conditional tests, loops, and functions, so that we have the essential building blocks to program. Then, in putting it all together, we look at the distribution of prime numbers. This is a small program which should not take long to write and uses what we've learned. The answer is also known, so there is a right answer and we can check that we get it. In the next 3 videos, we begin learning R, the special commands and data types. We start with the various data types, like vectors, matrices, and data frames, and then look at how to examine data with a range of commands like structure and head. Finally, we add more commands to pick out elements with certain features, using subset or which. With our new toolkit, we move to looking at more complex data. First, with the Titanic dataset and trying to make sense of it, and then adding value from our tennis data. Finally, we get some data from the web, which is messy. We show how we can use our commands to gradually clean it up. 80% of data science time is spent doing this kind of thing, since you don't just get neatly organized tables of data. Here, we're at the first video of this section. In this video, we'll see that R can deal with numbers, strings, and logical variables. We can add, multiply, and divide them, and we have arrays. R is pretty similar to other languages, if you programmed before. So, within RStudio, this is the programming window. I can comment by putting a hash symbol at the start of the line. We can print like we did before using the print command. So I just click run to execute this line, and we should see the result in the bottom left window. So print hello world, and the result is hello world. We have the standard data types like integers. So I can just go x_int is equal to 0. And then when we look in the environment tab, we can see that there's a variable called x_int and it's equal to 0. If I just type x_int, it shows up in the console and it's equal to 0. I could also just go print x_int, which also produces 0. X, less than minus is kind of S syntax. But we can also just use equals, which is what I do most of the time since I'm more used to programming in C. So we can go x equal to 1, and we can see that that shows up in the environment. So we have a variable called x, and it's equal to 1. And if I just type x, it produces 1 in the console. We also have real numbers, like pi, say, 3.1415. I don't have to go x_real, I could just call that x. So if I go x_real is equal to 3.1415, it shows up in the environment. If I just type x_real, that should print the value. x_real, that's equal to 3.1415. We also have logical variables. So I'm just going to have xLogic is equal to true. So they're like Boolean logic, where you have true and false. So I just execute that. So xLogic is equal to true. And if I just print it, we have xLogic, and the value is true. So in Boolean logic, true is 1 and false is 0. So if I go sum xLogic, it just adds the value, I get 1. If I go xLogic is equal to false, so if I then print xLogic, it says false. But if I look at the value of xLogic, it's equal to 0. That's a handy trick we can use, since we can have data where we know something is true or false for each of the rows. And using this, we can easily count how often it's true. That's something that we'll be using again and again. We can also create arrays. So if I go A is equal C for concatenate, it just creates an array with values 1, 2, and 3. So I just go A is equal to C 1, 2, 3. And then if I print A, we can see the values are 1, 2, 3. One-dimensional arrays are called vectors. So I could also have x vector is as vector C12. And I get the same output. So x vector, I get 1 and 2. If I go 1 colon 10, I can produce a sequence 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I go A is equal to 110, we can see that A is an array with the sequence 1 to 10. If I go sum A, it'll just add all numbers in the sequence. I can also go B is equal to A times A. So what would that mean? I mean, A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What would A times A equal? Put that in here. B, 1, 4, 9, 16, 25, 36. So if I multiply two vectors, it multiplies them element by element. So the first element of B is the first element of A multiplied by the first element of A. The second element of B is the second element of A multiplied by the second element of A, and so on and so forth. If I go sum B, it'll just add those numbers up, and we get 385. We can also do logical tests. So I can go test is equal to A greater than 3. Again, what would that mean? Well, we can just go test, and we can see the result. False, 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 true, 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 true. Okay, so like before, it's just done element by element. It looks at the first element, which is 1, and checks, is 1 greater than 3? False. Oh, this is A greater than 3, not B. So is 1 greater than 3? No. False. Is 2 greater than 3? False. Is 3 greater than 3? False. 4 greater than 3? True. So all these are true. So it does an element by element test. Then I can go sum test. Well, we saw that we have Boolean logic. So basically false is 0, 0, 0, true is 1. So when I go sum test, it just adds how many times we have true. I'll just run it. We get 7. As we'd expect. That's the number of times we have true. We also have strings. So I can go Z is equal to hello. So if I print Z, that's hello. I can also concatenate Z twice. And if I print Z then, I get it twice. So hello, hello. So R has the standard variables that we're used to. We have integers, we have real numbers, we have logic Boolean variables, and we also have arrays. In this video, we saw how R uses strings, numbers, and arrays.